Could mc² just be em if we used larger units for rem?
This answer is in 3. You need to keep the c² not because it makes it bigger but because it makes the units right. In C, E has units of J or kg, m2s2 or an m, and mass has units of kg, and C has units of ms, so you need the c² there so that you end up with kg m2s2 on both sides. Second, you can use whatever units you want for energy, mass and the speed of light, so you can end up with E, m and C having any values you want.
For instance, if you measured mass in micrograms instead of kg, then the numerical value of E would be much larger, but nothing has actually changed. Or if you measured speed in light years per millisecond, the numerical value of E would be much smaller. But of course, nothing has really changed. Just like if you measure your height in inches you might have a height of 72, but if you measured it in meters you'd have a height of 1.8, but they both are the same height.
But third, physicists actually really like setting C1 by measuring speed in light seconds per second. Doing this trick is called using natural units, and it allows you to say em for instance. This is why oftentimes you will hear a physicist say a proton has a mass of 938 MeV, which stands for million electron volts, which is seemingly a measurement of energy, not mass. That's because they are working in a unit system where C1 for convenience sake. And it's not just C1, you can make almost anything equal to 1.
A common used system is the Planck units where C, G, H bar and KB are all 1. This does make the math a lot easier, but you still have to be careful to make sure you keep track of all of your C's and G's, since if you want to convert it back into units that the common person knows like meters or joules, you need to use them to do the conversion.